So here we have our snap-on scan tool hooked up to the car. When you first plug in and turn the car on, you get this screen right here, which has scanner, OBD2, previous vehicles and data and tools. To access the car's data, we're going to hit scanner. Select what type of car is a Buick 2007. I'm going to hit automatic ID. Then it pulls up the VIN, the vehicle, which is 2007 Buick Lucerne, and the engine. And here we can see our codes and the data and test screen that we can do. So here we have our engine codes pulled up. Mr. Heisner nicely set a bug for us, which pulled up a UO107 code, which is lost communication with our actuator. So right now, we have our scan tool hooked up, looking at our engine data PIDs. We're at idle right now, and we do have a bug for the throttle actuator. And right now on the dash even says power to the engine is reduced. We can see that our idle speed is around 1100. Our coolant level is at 109. We are still warming up. Our MAF is at about 18.6. Engine load's at 44%. TPS is at 21. MAP is at 18.8. MAP voltage is at 3.21. Got about 30.1 in our barrel. We're in open loop still. We see that our oxygen sensors is around 30 for our first one. Our second one's around 13. We have 0 for our short-term fuel trim. Long-term is 6. EGR is at 0. Spark advance is at -12. So here on all data, we have the code pulled up, and we see that the conditions for running the DCC is the ignition is in the crank or run position, ignition voltage is more than 5.3 volts, and the communication between the TAC module and PCM must be valid. The conditions for setting the DTC is invalid or missing serial data messages or detecting for a predetermined period of time, or the throttle limit is seating while operating in a reduced engine power mode. Here we have the wiring diagram for the APP and TAC. And on this wiring diagram we see we have the throttle actuator control module, which is the TAC. And we have wires going down to from the sensor that goes to the APP sensor. And we have another 5-volt reference wire that goes to APP. We have our low reference for APP. And then also over here we have another APP sensor, which has a single 5-volt reference and low reference. And on top of that, we have some ground wires. We have wires that goes to the fuse block, to the fuse. And then we have our wires that go to the PCM. And we have our wires that go to the BCM. So here, our first step that it wants us to do is check the sensor single wires. And right now we have the APP sensor single wire 1 hooked up, and we should be reading about 0 volts, which we are. And then our next single wire would be light blue. And we're also reading about no voltage. Our next step is to measure our ignition 1 voltage when the key is off, ignition off, and we can see that we're reading about 0 volts, which is what it should be. So our next step in trying to diagnose this car is to get the voltage for the ignition 1 voltage when its ignition is on, and right now we have a 12.58 voltage, which checks out. The next thing to do is we're going to turn the car off, and we're going to check the voltage when the car is off, ignition's off, and it should be around 0. turn the car off, you gotta give the time for the ECM to power down. We see right there the ECM is turned off and the power is now going to 0 volts. The next step is to check the resistance in the ground circuits. The specification is 5, and we're pretty close to 5. The ohm meter is kind of weirding out on us, but it does check out to be close enough that it does check out to be okay. So here we're going to check the UART primary and secondary serial data. Voltage, the spec is supposed to be 2 to 5 volts. For the primary, we're getting about 0 volts. For a secondary, we're getting about the same thing, about pretty much 0 volts. So here we're going to check continuity to ground. First one we're going to do is our primary serial. Which we're not getting continuity. We're going to do our secondary, which we are not also getting continuity to. Our next test we're going to do is continuity between the connector of the TAC and the PCM. Right now we're going to do the primary serial, which got continuity. I'm going to switch to the secondary. Which also has continuity.